So it's noon. We're gonna wait just one more minute. We got most of you guys are ready, the one who are presenting. So I appreciate you being um so quick for responding to my emails. Really appreciate that. What we're gonna do today is we actually have a lineup of 8 speakers in total. We have Camilo Andres Salcedo, we have Derek Rice, Vatsal, Raicha, Ankit Pal, Vikrant, Deshmukh, Chitransh, Riyanshi, Bohra, and then we have Gloria. Gloria, sorry, I cannot pronounce your last name. I haven't been able to do it correctly for years at this point, so I apologize for that. Angwenyi, presenting here just different topics. They're gonna be talking about sensors. Camilo is gonna be talking about efficient placement of sensors. He's gonna be the first speaker. Then we're gonna have Derek talking about some data science slash health science. Just topics essentially. We're gonna have Vatsal talk about BERT, some text simplification in medical context in Ankit's talk. Then we're gonna have some internship experience by Vikrant, and it's gonna talk a little bit more about sarcasm detection, the context of machine learning, ML optimization specifically for Riyanshi, and Gloria is gonna talk more about fraud detection. So we're gonna get started. I'm gonna ask Camilo to start sharing his screen. Everyone will have roughly 5 minutes to present, and then a couple minutes of questions or just a buffer, essentially. We expect to be done within the hour with that timing. So, Camilo, you want to go first?
Yeah, sure. Thank you, Christian. Good afternoon, everybody. My name is Camilo Salcedo. I'm a PhD student at the Department of Civil Engineering, and also MS student in the Masters of Data Science. And today I will present this part of my research, which is called Clustering a Real-Size Network for the Efficient Placement of Confirmatory Sample Locations. A little bit of context for my research. I am working in the context of water supply networks, and I want to prevent the contamination that can happen because of an intentional attack, or also it can be a result of some bad operation in the system. So here, which is the main reason of doing my research, we want to avoid the potential health effects that we can have our population, and we want to do a quick detection and mitigation. In this case, our basic approach is done using sensors, but the problem is that sensors are expensive, and also they can be some limited in the specificity of the contaminants that it can detect. So the goal that I want to pursue here is that I want to characterize a contamination event in real time. So a little bit of how it is done is that we have here our real-size network. We will have a set of sensors that are taking information all the time. After that, an injection occurs. In the real life, we don't know where is that injection occurring. And then what we're going to do is that we're going to deploy a set of confirmatory sample locations or temporary sensors that will be able to give us more information on what is going on. So in this case, the objective is that we want to locate this set of sensors by using some information theory surrogate measurements. A little bit of the methodology. The first part of my research, I developed updating greedy algorithm, which is in charge of maximizing the information gain with a measurement that we call the expected network entropy. The problem is that we have this real-size network, which is located in a county in Florida, which has 12,000 nodes. For this network, the solution took around 140 minutes. We are defining the scope of real time as at most 1 hour. So we are here way above the hour. Also, what we can see is that some sensors or of these temporary sensors are lumped. The consequence of their being lumped is that we are going to have some information redundancy. This is going to be computationally expensive. And also, we are going to have some inefficient use of the resources. So a way that we find to reduce the redundancy and to reduce the size of the network is using clustering. In this case, we are using the k-means methodology, and we start analyzing, okay, what happens if we start clustering our network in just 15 clusters? We're gonna place at most 30 sample locations or 10 or 30 temporary sensors. If we place 15 of them, we can see that here most of the sensors are placed within the same cluster. But as we start increasing the number of clusters up to 5,000, we're gonna have that there are some sensors that are just in one single cluster. In this case, we took 5,000 because it is just an extreme value, because in real life, this is a high number. So in this way, by increasing the number of clusters, we can reduce the redundancy in information. Our second approach then is to define every cluster like a sampling unit. In this case, we're going to place a sampling location in the center of each sampling unit. And in this way, we're going to reduce the solution space from 12,000 junctions into just the number of sensors that we are defining as modelers. By doing these approaches, I'm going to show some results that I obtained after placing 30 sampling locations. So what we can see here is in the top of the screen, we can see a red line, which is the baseline. In the y-axis, I'm showing here the information gain measured by the expected network entropy. And in the x-axis, I'm showing here the number of sampling locations that I'm placing when the network is clustered in 30 clusters. What we can see here is that after some sampling locations, for example, when we define only 30 clusters, there is a point where this curve starts increasing again. That means that we are losing information. But also what we can see here is that the advantages of clustering the network between 1,000 clusters, 5,000 clusters, and using 12,000 junctions, it is really small, and there is a clearly trade-off in reducing the solution space and increasing the efficiency of the computational method. So here, that's what this line is showing here, that we can find or we can get a similar value of the information gain by using a reduced number of locations. In this side, I'm showing here that we want to use just an Intel i7 computer, which is something that a utility can have. And we can see that most of the sample locations, by clustering the solution space, we can manage this in a real time frame for a large network. So
1 minute, Camilo.
I just want to show you here the result for clustering, for placing the temporary sensors, which I got the solution in just less than 1 minute, and the redundancy is reduced. So finally, this approach is helping us to apply our methodologies in real-size networks, which is suitable for real time. And then what we discovered here is that we can use a sampling unit instead of using all the junctions as a potential location for the sensors. And future research will focus on using other information theory, surrogate measurements like the total correlation, to analyze the relation between these sampling locations. Thank you so much for your attention and your time.
Thank you, Camilo. That was great. Really appreciate your presentation. We don't have much time for questions, so maybe at the end we're gonna have like a buffer, and then folks can get to ask you questions. Okay, so now thank you, Camilo, again. We're gonna move forward. Derek, you're next. Yeah, go for it.
So my name is Derek Rice. I'm an MS student at high school. I also happen to be a reliability engineer at Medtronic, and primarily I work on prosthetic heart valves. And so what I'll take you through is say a problem statement. It's something we're trying to deal with, and then I'll introduce or show you pictures of prosthetic heart valves, aortic stents, and then we'll talk about an opportunity. So currently, these prosthetic devices are not instrumented. There are no sensors, so we don't do predictive health monitoring of the devices themselves. So we'll talk about the opportunity. Primarily, what's proposed is using a digital twin. And so I'll briefly discuss ideas on how to initialize a digital twin for this kind of a prosthetic device, and how would you possibly maintain it. So the problem statement here is that the reliability of these in vivo prosthetic devices is complex. It's an interaction between the device itself, medical procedure, patient attributes, and that are difficult to simulate during the DV testing or design validation testing in clinical trials. And so here's a slide that kind of talks about the types of things that we're discussing. So the images on the left, there are various configurations of prosthetic heart valves. And these valves, there are designs available for all 4 heart valves. So the pneumatic valve taking in blood, right? The tricuspid valve sending blood out to the lungs. The mitral valve bringing oxygenated blood back in from the lungs, and the aortic valve sending blood out through the aorta to the body. So there are designs for all 4 valves. And we're also here talking about aortic stents. So these devices, and they're here just to give you an idea how big some of these devices are. So basically, there are stents that for the ascending aorta, the descending aorta, and the lower abdomen. And then just combinations. So you can kind of see the complexity here. These devices here, they're primarily a sheet that might be plastic. It could be a textile. There's typically a 9-0 frame, and then there's an ankle system. Again, these devices get installed. Essentially there's not much in the way of monitoring. So there's an opportunity for digital twins. So particularly to do predictive health monitoring. So a digital twin is, say, an algorithm that is a twin of an actual application. So we use a lot in aerospace to monitor the performance of airplanes, aircraft engines, so that they can schedule maintenance when it's needed, as opposed to just at some frequency. So, in the case of a digital twin for a person, we have the person's initial health or their initial disease state. We have the prosthetic device and data from the design validation testing and the clinical trial. There's a lot of imagery or medical imagery that is available. It's not necessarily of high quality, but there is imagery. There's design data for all of the devices. So that's finite element analysis and physics-based models. So we know the stress, the strain as a function of shape. So the design is done assuming an optimized shape, but everybody's anatomy is quite unique. People that have these kinds of diseases, their anatomy is, how would you say, very atypical. Right? And then we know the life, right? So we know how these devices, say mechanically we know the life, and mechanically we know how the devices fail, right? And then there are best practices for the procedures. So we know if the device is deployed many times. So sometimes a doctor will try and deploy one of these devices. He doesn't get the position right. He'll withdraw the device and try again. And he might do that 2 or 3 times. Each time there's a change to the stress state of the device. So it accumulates residual stress that has a detrimental life. Right? So every time a redeployment or an adjustment is made. And then we know the patient history, the genetics, the lifestyle, right? And then there are empirical models of some of these relationships. And then it may be possible to, in some future time, to include sensors, additional inspections, biometrics, and then just the temporal field history of the device, population, or individual patients. And that may, if it's done properly, be able to give you a predictive model of at the device level, maybe at the device patient level. And so ideas on initializing a digital twin. Right? So this kind of thing might be new to some of you, but here you can see there on the picture on the right, they're placing an aortic heart valve. So they make a cut down on the femoral artery, so the upper leg and the inside thigh. They bring a catheter all the way up through your aortic tract, right? They come up over the ascending aorta, down to the aortic valve, and place and deploy. In this case, it's a prosthetic aortic valve. Right? That's what's going on in the picture. Right? So to initialize one of these digital twins, you have the finite
You have 1 minute.
analysis. Right. Okay, and then and then information about the patient and so forth, right? And then to maintain it, you would need to come up with a system of sensors, and that technology simply does not exist today. And so a lot of these sensors, if you're thinking of using sensors, they would have to be sensors that can monitor the biology in the body. Primarily, these things break down because the body attacks the textiles or the leaflets within these cells. Right? So the sensors would have to be monitoring biology. So in summary, right? So these in vivo medical devices are increasingly being utilized as life-critical therapies, right, for a large variety of disease states. Currently, there's design validation of clinical trials, but they're not going to capture the variability inherent in the use case. And then, I'll leave it at that. So, but I would say that this is a big opportunity, right? Unique integration of data science and engineering.
Awesome. Thank you, Derek. Appreciate it.
Okay.
Thank you so much for your talk. There is no time for questions, so I'm gonna move on. We're gonna move on with Vatsal's talk on BERT, but I appreciate you sharing all that information with us, Derek. Thank you. The floor is yours. You can.
So yeah, thank you, everyone. My name is Vatsal Raicha. I'm currently a student in the Master of Science in Data Science for the batch of March 2024. I'll be talking about multi-class text classification using BERT. In this case, basically, I've used a very small sample data set which contains newspaper articles and has about 4 categories in which the articles have been classified to, from politics to sports and entertainment and finance. And so just wanted to utilize the BERT model with a small data set and then provide it with latest news and see how it performs. So just a little bit about the data set. As I said, it's a very small data set. It's about 7,000 records for training and only 2 sections in the data set about the story and which category does it fall into. The data set had 4 categories. The data set is pretty balanced between the 4 categories, so I didn't have to deal with any imbalance as such in this case. Followed a basic methodology, did this using Google Colab, and by creating by going through initial pre-processing steps of utilizing NLP, of cleaning the data set and basically vectorizing it to be able to provide it as an input to the BERT model. Mainly, I'd be talking about I'll not be going to the code as such, but I would be talking about the experiences that I had with hyperparameter tuning of this model and the results that I had with this. So as I mentioned, I use the bidirectional encoder representation from Transformers model. I think it came out around 2017 and utilizes the advanced NLP techniques, which was built upon the sequence-to-sequence model, utilizing the attention mechanism. So in the initial phase, when I ran with the following hyperparameters, my learning rate was a bit fast, and the dropout was set to 0.5 and I had a batch size of 16. The model performed really poorly, and as you can see, the training loss and the validation loss, basically, they never really converged, and so I had to make modifications to the learning rate and the batch size. So let's see how it resulted in. So I reduced the number of epochs just basically to see if the model is converging at first or not. So, and I reduced the learning rate significantly and increased the batch size initially to 32. But So as you can see now, for the case of training, the model converged quite quickly for 10 models and didn't really see any benefits in the validation. As you can see that it stayed around the same. In fact, the loss increased, and then, didn't really see a performance improvement as far as validation is concerned. So basically, in this case, I just saw the model overfitting into what the data was, or not learning anything generic to be able to perform well on unseen data. So then going forward, I increased the epochs to 50 and reduced the batch size significantly to 4. So the model took significantly longer to train. It did converge significantly on the training data. As you can see that it has the loss died down significantly. In case of validation, as you can see, it dropped a little bit, and from there on, it kicked off quite a bit. But what I was expecting to see was, if I had more processing power, I could have probably continued with more epochs and probably could have seen a downward trend here as far as validation is concerned. So let's see, I left it at that, and I could have probably continued tuning this had I more resources and more training data. But I think in this particular case, the not having a lot of data is basically resulting into what I have with here with the validation loss. So it basically, I picked up some news articles from October 23rd last month, and last month all of this thing was going on with selecting the speaker and stuff, and so it correctly identified that article as politics. It didn't really understand what cricket was, so it identified it as politics. It identified the Qualcomm announcement properly as technology. The release of the new Mission Impossible movie as an entertainment.
You have 1 minute left.
Yeah, and here JP Morgan was CEO Jamie Dimon was talking about business and politics, but it misclassified it as entertainment. Basically, this particular article probably could have landed into multiple classes. So let's see. So the model performance was basically, in case of validation, it didn't do really well, but the training improved significantly given I reduced the batch size. I reduced the learning rate, reduced the batch size, and increased the number of epochs, which improved the performance, but probably overfitted. One of the reasons for that was I had limited training data. Some of the articles were impacted by multi-class, and I need to take care of that. As I said, collecting more data, providing your tuning with the hyperparameters, and handling multi-label situations is something I look forward to working on this to improve the performance of this model utilizing BERT. Back to you, Christian.
Thank you, Vatsal. You have a final slide, don't you, with that acknowledgement? Is that correct? Oh, well, it's just that one. Well, thank you so much for your talk. I appreciate it. We're gonna move on with Ankit's talk. We don't have time for questions, that's all, but thank you so much. And maybe at the end we'll have a set of questions for you. So, Ankit, do you wanna go ahead and share your screen? Yeah, perfect. Yeah, go for it. Thank you.
Thanks, Christian. Hi all, I'm Paul, and I'm going to present today reproducibility-driven development of medical text simplification tool. First, why do we need to simplify medical text? As you know, medical texts are very hard to read because of limited health literacy. So simplifying text can reduce this barrier, and there are only limited tools that currently can do that. And what do we do to simplify text? First, we are developing text simplification tool, and also we do conduct research studies to identify like what makes a text difficult. So this is one of the demo for our tool where we can paste the text and we can see some like statistics related to that. And also we can see some visualization that will come up in the demo. For example, all these metrics that you can see for the particular text. And after that, like going to the visualization, you can compare your text with different kind of corporas like blogs, podcast, Wikipedia, like whatever we have collected data from. And also for the text, you can also generate audios with different attributes like maybe gender, voice. So this is pretty cool in that sense. And how do we develop this tool and how do we develop the research studies content? So we do web scrape from different medical texts that I just showed you, like Wikipedia and journals, blog, podcasts. And after that, we collect 34 metrics from these texts using like our Python scripts, which about like word count, nouns, verbs, adjectives, and lexical chains, and some of the metrics that we have come up with from the research papers. And we also, for the studies, we also generate questions and answers using GPT 3.5 model and species. And we use these in like research studies to get answers from people using the Amazon MTurk studies. And we also generate audios like that I mentioned before. So we generate the audio from this text and we use Azure speech service to generate the speech. And we also like generate the speech score, like pronunciation score, or like how the score of that particular audio is. So all of this is done using like different Python scripts and different tools. And the thing is like how to make all of this reproducible. So first, we maintain all of our code in this GitHub repository, and we so that we can track changes, what is happening in the code. So that helps us in that. And also we try to make our code modular. As you can see, like we have different kind of structure for scraping, for NLP utilities, and also the data. This is just temporary data, and all of this is documented in the GitHub repository. After that, as you know, like we maintain all of the code mostly in Python, and we use like different kind of libraries. The problem with Python libraries is like if we keep changing on, like if we run it in the future, there is a possibility that it might not run because of like version upgrades or anything. So that is quite possible. So what we do is we used a package version management called Poetry that is very easy to use. You can create your virtual environments and you can either build on packages. And so this helps us to fix our package versions so that whenever someone tries to run the code in the future, they can execute with the same code and it doesn't fail. So it makes it more reproducible. After that, we also make, even though like we have made our code reproducible by using the same versions, but it can happen that some user is using different OS and different architecture, and that can still fail your execution. So in that case, you should use something like Docker. So we have used Docker to execute all our Python scripts using Poetry. And one of the example of Docker command is something similar to this. You can pass your Python file and all the arguments, and anyone can just like build the Docker file, build the Docker container, and then just run the script. So this makes it more reproducible. And even though we have like everything maintained in like Python scripts and Docker, but we still have to lay out the instructions for the new user. Like if someone new is coming into the team and they have to run this. So we make all of our code documented in the GitHub repo itself. For example, how to run the NLP stats, or how to run the audio files, or generate the questions for the study. So all of this is documented something similar to this in the GitHub repo. And finally, like we have this, once the Docker file runs with the Python command, and then we create this data, like maybe scripts, audios, or like questions, then we have to keep this data somewhere so that it is not archived or not deleted at some point. So because of the data is present in temporary directory, we move it to Google Drive or S3 for the archival and storage, so that it is there for everyone's use in the future as well. So these are the things that you can use to make your code more reproducible, and for making it more step towards open science. For this project, we are supported by National Library of Medicine. this grant is provided by them. And also like I'm part of R4R program, Roots for Resilience program, which helped me in developing these academic research skills and motivated me to work as per the open science approach that I just showed you. And this program is also like we work with different researchers from different fields that help me to understand data science and machine learning in the other domains as well. And that's it. Like, thank you.
Awesome. Thank you, Ankit. Appreciate it. Thank you for your talk. There was a news coverage this week for Ankit's work, so I'm sending it in the chat. And in case you guys wanna read it, we have 40 seconds to ask questions, but I rather, Ankit, maybe folks are gonna ask you questions at the end, so we can just stay in time essentially. I'm gonna let Vikrant go next.
Well, hi, good afternoon, everyone. My name is Vikrant Deshmukh. I am a data science student at the University of Arizona High School. I'm from the 2022 batch, fall 2022 batch. And as for my presentation, I would like to talk about my internship experience at a pharmaceutical company called Roche. And just to give a big background of what the company is about. So Roche is a Swiss multinational healthcare company that operates worldwide under two divisions, which is pharmaceuticals and diagnostics. And during my internship, I was working under its biotech arm called Genentech, which is a biotechnology company based in United States. And during my internship, I worked on site with a lot of scientists and data scientists, which were involved in analyzing biotech data. So just from these pictures, you can see there's a lot of instruments that are specifically designed to collect, process and analyze a lot of biotechnological data, biochemical data that is generated for drug substance manufacturing. And these instruments are pivotal in understanding the living organisms, disease mechanisms, and the bioburden data that is within the drug substance that are generated. Hence, as these biotech equipments generate a wide range of data, including genomic and cellular data, it is very vital for the business to analyze the data and generate meaningful insights from it. So during my time at the internship, I was working with a lot of qualitative data that came from a lot of different systems and scientists that were operating on the systems in real time. And so to analyze this qualitative data, I used a lot of topic modeling initially. And from this, you can see, just to give a gist about topic modeling, it's like a basic statistical modeling that uses unsupervised machine learning to generate clusters or group of similar words within a body of text. So if you provide a group of text, it will run some algorithms in the backend, and it will give you clusters of words that are similar. And this mining method uses semantic structures in text to understand the unstructured data without predefined tags or training data. So you can use unsupervised learning on this. Another thing that I worked on was using a very popular library called scattertext in Python. And this is a Python package that lets you interactively visualize between two categories of text that are different from each other. And most of the work that I've done on scattertext focuses on how you can visualize the differences in single words and bigrams, and how these different words and frequencies are related across different categories. Of course, I can't share the actual visualizations because of confidentiality agreements with the company, but this is just a sample of what work I was doing on. Another interesting project that I was working was building custom chatbots for summarizing a lot of drug substance data that comes through. And this is qualitative data. Hence for this, I fine-tuned a lot of Llama 2 and Falcon B40B models on AWS SageMaker for different use cases. So scientists used to reach out to our team and discuss their use cases, and we used to fine-tune the model and build data pipelines for training these models and generating chatbots. So from this example, you can see you can just you can query the model and it will give a descriptive answer about the underlying data. So that's one of the projects that I'm currently working on. And this is just a visualization of what the business process was. It helped the business save around $150,000 in the span of 6 months, because they had to eliminate a lot of manual processes in the back end So there was an enhanced root cause analysis. So just by querying the data on the model, you could pretty much get a general idea of what the trend is among drug substance manufacturing, unplanned events, event breakdowns, machine breakdowns. And that led to the next project that I'm currently working on, which is based on predictive maintenance. It is a very popular topic among data science. I can't share the actual architecture of it, but this is just a gist of it. So I'm using AWS and a tool called DataIQ to build the ETL pipelines to analyze covariate analysis and see which kind of sensors that are used in automation affect the end product. So that's just a gist of it. And as per acknowledgement, I'd like to thank the on-site team that allowed me to work on these projects. I got to visit different sites in South San Francisco, in New York, and Oceanside. They allowed me to go to the site and actually be there present and work on the substance itself. So I also like to thank my manager, Maximilian, who is the chief of staff, and my co-partner, Nikita, who was working with me during this internship. That was it. Thank you.
Thank you, Vikrant. This was super complete, and thank you for being on time. Yeah, I'm still gonna move forward. Well, I'm gonna let folks. Do you guys have any questions? Anyone wants to ask a question? Should we move on? Great. Okay, so yeah, our next speaker is gonna be Annie. Annie's gonna talk a bit about sarcasm detection. So.
Hi everyone, my name is Chitransh. I am a second-year graduate student at Department of College and Social Behavioral Sciences, and I am doing Masters in Data Science. I'm going to present today sarcasm detection. So sarcasm detection, it is a natural language processing task which involves identifying sarcastic statements in text. The traditional methods that were already present in the market for sarcasm detection have focused on basically analyzing individual statements. But the recent advancements that we see in deep learning transformers, they have opened up the possibilities of utilizing additional contextual information to improve the accuracy. So in this project, we investigate the effectiveness of using contextual information from conversations to enhance the sarcasm detection using Roberta, which is a popular deep learning transformer model. Okay. So there are some terminologies that we I would like to discuss. I think sarcasm, everyone knows it is a form of verbal irony in which we intend to say something that we don't mean actually. For example, if I say, I love waiting for hours at the doctor's office, I'm likely being sarcastic because waiting for a long time is not something I would really want to do. Second thing is contextual information. It actually refers to the information that can be used to understand the meaning of a statement. For example, if I say, I love it here in front of a burning building, of course, it is clear that I'm being sarcastic because literal meaning of the statement does not make sense in the context of what is happening right now. Second thing is conversational context. It is a type of contextual information that is specific to the conversation in which a statement is being made. For example, if I say, I can't believe you just said that, it is an argument. It is clear that I'm referring to something that was previously said or happened. So yeah, the third is utterance. Utterance is an individual sentence. It is a part of a larger sentence. For example, like I gave the example of, I love waiting for hours in the doctor's office. So at the doctor's office would be the context, and I love waiting for hours would be an utterance. There are some research questions that actually was intended to find in this project. First was, how much contextual information should we provide to the model to predict good accuracy? Also, there are different categories of sarcasm. What categories should we do to present the good accuracy of the model? Let's talk about the input and output. The input to the problem would be a conversational sample, including some sarcastic sentences, and the output will be a binary label, that is 1 or 0, for the interpretation of the sarcasm, where 1 indicates a sarcastic comment. There are 2 data sets that we would be looking at. I would provide more information later as we go. So there are some performance baselines that we did. So random means we select 3 baselines to use per each data set. Baseline 1 random is achieved by randomly selecting a sarcasm label for each example. Because this is a binary classification problem, it is expected to be correct about 50% of the predictions. Baseline 2 is positive label that selects the positive labels, which identifies all comments are sarcastic, and then we compare it. Heuristic baseline is commonly used as a rule. For example, if I say we have to predict like how much how many sentences do we have that starts or ends with like, this is a heuristic rule. So we predict the sarcasm label on this level. Otherwise so what we do is, so we see that how many times like occurs in a sentence, and that is how we predict. Otherwise, we predict that the utterance is non-sarcastic. We report the baselines for the data sets that we will use for both experiments. For the F1 score of both data sets, we find that the positive label performs the best because the database is relatively balanced, and a recall of 100 inflates the F1 score. However, using the heuristic baseline method, we are able to obtain significant increase in accuracy and precision for both data sets while maintaining high recall. So we are using 2 data sets. First is sarcasm for Reddit, that is taken from Reddit website. And the second is news for headlines for sarcasm, that is taken from Twitter. We have divided the SARC data set, that is for Reddit data set, into 80:10:10. That is 80 for train, 10 for test, and 10 for validation split. I don't have that much time to talk about the data set, so we'll move forward. We are doing 2 kind of experiments. For experiment 1, we'll train multiple Roberta models with the input specified. Roberta is, as we know, a popular transformer model that attains current state-of-the-art performance of multiple data sets through leveraging additional training data and hyperparameter optimization. For each input, we train a new model that is provided varying degrees of the utterance that we talked about and contextual information as well in varying order. For example, first we took 1/3 of the contextual information, then we take 2/3, then full lines of preceding contextual information, and then we'll compare the results to a selected baseline. This is the exact result that I was talking about. We observed that all the models trained have a substantially higher accuracy and precision than the baselines we talked in table 1. We also observed that the input combination of C plus U, that is contextual plus utterance, performed the best for most of the metrics, as it contains the full context information, in addition to the utterance in the natural ordering that they appear in the comment thread. So what we see is,
One minute, Annie.
Yeah, I would talk about the second experiment now. The second experiment, basically, we take the data set that was from Twitter. So it aims to evaluate cross-domain sarcasm using the data set, comparing models trained with and without the context. So in addition to the above experiment, this involves best performing model for experiment 1, that was context plus utterance, to evaluate the news headline data set. I would just jump to the table and the result. So based on this table, we can see that when not provided with the contextual information, that is the C plus U model, performs poorly and matches the baseline performance. The U model performs above baseline, but not as well as the news headline dataset on the previous dataset that we used. So in addition, I would like to conclude about both the experiments. For experiment 1, we see that when given full contextual information, that is C plus U, C means contextual and U is utterance, we obtain a higher accuracy than without the contextual information. We demonstrate that Roberta is able to utilize additional conversational contextual information to more accurately and more precisely predict sarcastic comments. For the experiment 2, we see because the U model performs better than the baseline, we believe that there may be some elements of sarcasm detection that can be transformed from the domain of online discussion to the domain of formal news headlines. But because of the large decrease in the performance of the previous data set, we believe that some elements of sarcasm detection do not generalize. Maybe this is because of the largely formal or informal domain of Twitter, or when compared to the casual conversation on that we do on Reddit. Yeah, that was all. Thank you.
Awesome. Thank you so much, Annie, for sharing your work. Really appreciate it. Riyanshi, you want to go next?
Okay, so good afternoon, everyone. My name is Riyanshi Bohra, and I'm a first-year graduate student studying data science from the School of Information. And today I'm going to be talking about a project that I did in collaboration with PricewaterhouseCoopers as a data science intern in the Data and Analytics division. The project was related to the pharmaceutical manufacturing industry and was titled Machine Setting Optimizer. So to start off, I'll give everyone a very brief idea of how the tablet manufacturing industry works. So there are broadly 3 steps involved, but our main focus was the compression machinery. So in the pharmaceutical industry, the traditional approach to manufacturing is the trial and the error method. But this has multiple disadvantages, including high material wastage, increased cost, over-reliance on manual adjustments, and loss of yield. So our objective was simple. Our main goal was to transition from a traditional trial and error approach to a data-driven solution. So we aim to build a tool, a machine learning model using historical data to predict the optimum settings of a tablet manufacturing machine. So these included parameters such as pre-compression force, tablet filling depth, main compression force, and others. Through this, we hope to achieve the right quality attributes for our final tablet, which were in the form of weight, hardness, and thickness. So by doing so, we aim to enhance yield, reduce cost and waste, and automate the entire production process, leading to efficient use of man-hours. So I'll quickly go over the workflow here and I'll explain it further in the next slide. But the first step was to create a design space for the entire project. Then we moved on to the design of experiments for process optimization. Next was our feature engineering, where we performed feature selection and dimension reduction on the dataset. Then we moved on to building a model through predictive analytics. And then finally, we created visualizations using Power BI for our clients. So explaining further, our first step was to create a space that represents all of the combinations of the input variables to ensure that the CQA, which is the critical quality attributes, are met, which is the optimum value of our target variables. So then that was the first step. The next step was to create experiments to find relationships between the critical process parameters and the CQAs. Then we move on to the feature engineering and selection to find out which process parameters are the most relevant ones for our purpose. And then we trained our models using supervised learning techniques and tuned our final random forest model using randomized search CV. Finally, we built dashboards with interactive visualizations for our key stakeholders. So this is one of the example of a correlation heat map. I couldn't use the actual heat map, but this is an example of the heat map that we created to find the relationship between the process parameters and our target variable weight to find out which features are the most relevant ones. So we created 2 more heat maps for other target variables, which were hardness and thickness, and evaluated the correlation for them as well. So the results were remarkable. We used a tuned random forest model because it did the best job of dealing with overfitting for our data set. And here are the performance metrics which indicate the model's precision in reducing the prediction error. So we use several metrics such as MAE, MSE, RMSE, and MAPE to evaluate the accuracy of our model, which came out pretty good. So this is an overview of the entire process. It started with data management, moving on to model development, where we selected our algorithms. So we selected 3, out of which random forest was the best one. Then there was model validation through cross-validation. And then finally, there was scaling the entire solution and integrating it into a live production environment. So yeah, this is an acknowledgement dedicated to PwC for giving me the opportunity to contribute to this project. And yeah, thank you for, I just want to say thank you for giving me the opportunity to present today at the MSDS Lightning Talks. It was really great hearing about all of the other people's projects, and I'm really grateful for this opportunity. So yeah, thank you, everyone.
Thank you, Riyanshi. That was a lovely talk. Thank you for sharing your experience and yeah, what you have been up to recently. That's awesome. I'm gonna move on with the last talk. Gloria, you're next.
Hi, everyone. I'm going to start my presentation by a few definitions of terminology. So data democratization is basically the process by which institutions open up data to other employees within the institution and also to third parties. So in the case of banking, we think of companies like Google, technology companies, and Apple, and all those companies. Then, of course, as we shall see later, is that with the data democratization process, we are able to come up with various innovations. And also at the same time, fraud kind of revolutionizes and changes. Fraudsters are keep on changing their tact. So we look at banking pre-internet. It involved only a select employees having access to the data, and the data was not highly distributed. And of course, it wasn't easy to transact. You had to go to the bank and get physical currency. And of course, theft was carried out in person at gunpoint or whatever. Then post-internet, we have more employees and third-party companies having access to this data. And theft and fraud has changed with the change in the technologies that we use, and more data is being collected about the consumer these days. They'll collect about the places you're going, the shops you're buying from, and all that. So the questions for my study were, has increased data democratization in the banking sector led to increased fraud? And do we expect a similar trend in future? And are banks justified to use transaction amounts and balances as determinants of fraud? So I went through the evolution of banking, but I'm just going to go through this quickly. We see that banking was formally institutionalized in the early 1900s with the establishment of the Federal Insurance Corporation. And then, of course, the first credit cards before the internet were not really, they were just paper cards with a magnetic chip. Then the automatic teller machines, they were not distributed. But now from 94, we have now, with the internet coming in, we now have online banking, and now app-based banking around 2011, 2007, the mobile banking. But that is in the US. I'm going to boast a little bit. I come from Kenya, and the first ever mobile banking platform started out in Kenya before smartphones. We were using USSD technology, so you can Google M-Pesa. It's something we use a lot in East Africa. So I got some data from the Federal Trade Commission, although it's very difficult to access the data, but I got a bit of data about the complaints between 2001 and 2022, fraud complaints. And as you can see, the complaints kept increasing, and my eyes go to between the year 2020 and 2022. There's a peak, there's a slight peak, and then it goes back to normal. And this, I'll attribute this to the COVID period. More people were back at home and more people were transacting online. We had companies like Amazon hiring extra employees because they're now experiencing a surge in consumers who are using the platforms. And then here I took off the data from 2019. And this is the contact method that was used to commit the fraud. And you can see the total money lost via phone fraud. It's a lot. And I believe that because the minute I landed here, the first fraud I was getting was for Amazon Prime, even though I hadn't started using Amazon Prime. Was fraudsters just trying to get into my banking information using the Amazon Prime phishing scam. Then, of course, website, email, and all the others. Then here, for 2019 also, something that really struck me is that the younger generation are more likely to report when they get defrauded, as opposed to the older generation, 60 years and onwards. I'm not really sure why, because they also happen to be a special target for specific scammers. And then I came across a bank fraud data set. It's shrouded in a lot of secrecy, but it's real data from an African institution. And the person who posted this data set originally online didn't give a lot of information about it, and it's understandably so. It's banking data, and banks are very possessive of their data, and it's very sensitive information. But the good thing is that the data set is highly anonymized, and yes, it's been used a couple of times. So we look at the features which separate the genuine from the fraudulent transactions, and you will see there's the error at the destination account and error at originating account. So an error at the destination account within the data set, according to what I saw, is that, for instance, the destination account is the balances are very negligible, like maybe $100 or less. And then all of a sudden receiving a certain amount of money that is not the norm for that account. Then an error at originating account, I noticed, is a case where the amount being transacted, and mostly these transactions for fraudulent transactions, it's mostly cash out or transfers of money. That's something which really defines these fraudulent transactions. So an error at the originating account mostly comes about when the amount being transacted is very close to the original amount. So, and this is the correlation matrix to separate the fraudulent transactions from the genuine transactions. And of course, you can see for the old balance of the originating account and the amount, they are very highly correlated in fraudulent transactions. So I applied a gradient boosting and neural networks algorithm to predict fraud for this database, for this data set. And you will notice that there's a class imbalance. The number of fraudulent transactions are a lot less than the normal transactions. So that's why I decided to use the gradient boosting, because it kind of autocorrects this, it automatically corrects this problem of class imbalance. And with XGBoost, I was able to get an accuracy of 99.86. I was using the attributes which are related to transaction amounts, bank balances, and accounts which have been flagged as suspicious or fraudulent. Then the accuracy for neural networks was a bit lower. But again, you need to know that for neural networks, it doesn't have an internal mechanism to deal with class imbalance. So what I did was to do an oversampling an undersampling of the less predominant class, which is the genuine transactions. So yes, and that was my conclusion. The information age has facilitated transactions and opened up borders, and the internet, of course, has opened up transactions and consumer information. It's very possible to get defrauded from a continent away, by someone from a continent away. So it makes authorities find it difficult to trace proceeds of fraud. And then also younger victims are more likely to report fraud. Thank you.
Thank you, Gloria. Thank you so much for sharing this information with us. I'm gonna just share my screen one more time. I think it's on the hour now. Thank you, everyone who joined today. This is gonna be recorded. Well, it's recorded and it will be posted on our social networks in case anyone is interested. But thank you for joining, and thank you for talking here. Camilo, Derek, Vatsal, Ankit, Vikrant, Annie, Riyanshi, and Gloria, for sharing your work and your experience with us. So I'm gonna wrap up the meeting right now. If anyone has any questions, I think that you should definitely reach out to the folks who presented, or yeah, just essentially try to get in touch with them. Here is her email address. But thank you everyone for joining and for presenting.